To begin comparison of two groups for a mean or two separate populations, which is what we'll be trying to show with the t-test, if they come from one group or two groups, we'll look at the MRSA regions data. Make sure you create the east-west data on your own following the video that showed you how to create the region and subregion. And the east-west column is very simple. Just take the region column to create groups by east and west. And what we would want to do for the preliminary analyses is do the distribution menu. We'd want to look at east-west, and we'll use the year 2011. And from there, we get the preliminary information about the breakdown of the number of states in the eastern region and the western region. And this is the N to start with. We'll have to note how many N we have missing here. So we only have 42 states in the 2011 data. So we'll have to determine where they are missing from. And we can then report the overall percentage of antibiotic-resistant MRSA infections for 2011. To then start with looking at it by the east-west regions, we'll go to Analyze, Fit Y by X. We will put 2011 in our Y response and east-west as our X factor. You can see here that with a Y response, right here, and with a red categorical variable as our X, we'll get a one-way ANOVA. ANOVA stands for Analysis of Variance. A t-test or two-group test is the simplest form of an ANOVA, and it was actually invented first to compare two groups, and then the analysis of variance was developed later for two or more groups, but they're generally considered an ANOVA or a t-test, and when it's just two groups, you'll specify it as a t-test. So at any rate, we'll press OK, and you get this plot that's very basic. Essentially, what it shows you here are the points of our percentage resistant for each of our states in the east and west region. You'll notice here that east takes up more of the x-axis than west. This is called a proportional axis. East has more states than west, but you generally won't do that for publication, and you'd want them to be equal. So under the red arrow, under display options, you can remove the x-axis proportional. And you'll see very quickly now that east and west have equal distance on the x-axis. You'll also see that we're missing 10 rows of the data. JMP is very good to let you know that you are missing 10 rows. We know that we have 42. We will find out where those 10 are missing from a little bit later. Right now we can see the points are all in a line. So if we have two states that are very close here, it'll be hard to tell them apart. You can, under the red arrow, under display options, ask for the points to be jittered, and then JMP will show you a horizontal spread. Now, you shouldn't interpret this. There is no rhyme or reason to the amount or distance away from the center on the spread. Essentially, what it shows you is it just pulls out points that were overlapping. You can also see that we have the overall mean bar here. So this tells us where the overall mean is for the east versus west for all of 2011. Some other things that we may want to look at would be a box plot. And so again, under display options, we'll ask for the box plots. And from here, you can look at the whiskers and the center and the quantiles. This is the first place to start looking at normality for the data. You should see symmetric box plots or you will see with normal data. We have a little bit of an issue here where we can see that our lower tail here on east is shorter than the upper tail, which means we have a few more outliers in the upper part of east. You'll also notice if you click and drag, you'll notice the highlighted rows here in the data set that you can very easily find any outliers. So if I click on this point, it'll be selected in the data and I could go back to the data and find that that is 70% positive for 2011 for antibiotic resistance. That occurred in Nevada, in a western state. So that helps you with some data diagnostics as well. So we can move on to look at the actual summary statistics for the data, and we'll start with the quantiles. Here you can start to look at the spread of the data. So the 25th percentile to the median and the median to the 25th percentile would be equidistant in normally distributed data. Here, the 25th to median looks to be just about 8 points. So we've got 6 to 50 plus 2 more, and then here we have about 8 points. And then we're looking at less distance, about 4 points for the Western group. Now, we should see the same distance for the 10% to the 90th, and that's actually, we can see here is about 14, whereas this is about 13, and then the minimum to the maximum, we actually see 12 versus close to 22. So we're looking at a little bit different of a spread under East. West looks relatively symmetric, excepting our single outlier here. If this was truly normally distributed data, the distance between the median and each of the percentiles would be equal. But just because they aren't doesn't mean it isn't normally distributed. And we know from single means that the way we address normality is with the normal quantile plot. So we'll go here to look at the normal quantile plot. Normal quantile plot, actual by quantile. And we'll make this just a little bit larger so that we can make it a little bit easier to see. What we want is the same as in a single mean. We want the points to follow this straight line in a relatively straight fashion. We have a little bit of departure from that on the tails, but we often saw that in the normal quantile plots for a single mean. So let's actually very quickly bring up the distribution for 2011 and ask for the normal quantile plot here so that you can compare the two. And you can see here that we also have a little bit of wiggle in the tails for 2011 overall, and a little bit in the wiggle here. In 2011. So we would judge 2011 to be normally distributed overall, and I think we aren't seeing any departures here either from normality. From there, we'd want to then go ahead and look at the means and standard deviations. Since we've deemed normality to be appropriate, then mean and standard deviations are appropriate summary statistics for the group. And so we'll ask for means and standard deviations here. And you can see now we've identified where our missing are. Our East had 27, so we're missing 2, and our West had 25, so we're actually missing 8 in the Western states for 2011. The disequality here, the inequality, isn't incredibly important. We will talk about the situations where unequal numbers can cause some problems, but for right now, we'll go ahead and move forward with summarizing this data. We can see that the mean percentage for Eastern states for antibiotic-resistant MRSA is 52.8. We can see that for the Western, it's 43.8. So there's about about a 9-point difference here. And we are showing the standard deviations, which is how we describe the sample. We have the standard errors because those are used for the 95th confidence intervals, 95th percentile confidence intervals, or 95% confidence intervals. Remember, with a t-test, standard errors in relationship to the difference in the means is essentially what the t-test is showing us, and t-scores larger than 2 tend to be interesting to us. And here we're looking at 9 comparison to 3, so that may indicate a difference in means that we would determine in the t-test. We'll look at the t-test in future videos, but what we want to look at here to summarize is that we can look at box plots, we can look at the distribution of the point spread by group, we can assess normality, we can look at the centers of our distributions with the median and the mean. Remember, in normally distributed data, the median and the mean will be identical. Here we're actually seeing them to be quite close. And in normally distributed data, we'll see equal spread with the quantiles. Here, it's actually all right until we get into the tails. For normally distributed data, we would want the points to be along this line, and we do see that. And in addition, we now have some information about our missing data, as well as what our means and standard errors are, as well as our confidence bounds about those means, to look at comparing them with a t-test in the next video.